welcome back. So in this second section of 7.3, we're going to continue developing the ideas we talked about yesterday, or that we started developing yesterday. Okay, so there are two big ideas that we focused on, all right? One, can we go back and forth between logarithmic form and exponential form of equations? Okay, because remember, logarithms can undo the base to set free an exponent. It can solve for an exponent. So when you look at something like this, okay, I see it has this base 3. So what I'm going to do is I'm going to take the base 3 of both sides of this. And the reason I'm doing that is because now it sets free that exponent. All right, so log base 3 of 1 equals 0. So again, it's answering the question, what power does 3 need to become 1? Well, it needs a 0. Same thing here, I see this base 2. Okay, so I'm going to log base 2 both sides. And in doing that, again, it breaks free that exponent. So answers the question, what power does 2 need to become 1/8? Well, it needs a -3 power. Or this one right here has a 64. So let's use base 64 to set it free. So again, those cancel off. So it answers the question, what power does 64 need to become 8? Well, it needs a 1/2 power. So again, that is to help you go between the two forms of equations. All right. The other big idea we talked about is simply, can you evaluate basic logarithms? Okay. And remember, the big idea here is the logarithm answers the question, what power does 2 need to become 8? Well, what power does 2 need to become 8? It needs a 3rd power. What power does 9 need to become 729? Oh, sorry, wrong one. So what power does 9 need to become 729? Well, also a 3rd power. Remember when it's not written. So here, this common logarithm, when there's no base written, it is a secret 10. And what power does 10 need to become 100? Well, it needs 2. 10 squared gives me 100. And then finally, ones like that last one gets to the very nature of what we're doing. The log cancels the base and literally just leaves you with the exponent. Okay, so again, those are the basics we talked about yesterday. All right, but remember, we did talk about another way to think of these. So for example, if we go back to that first example, we talked about 8 is 2 cubed. Okay, so that's really what's happening here. We're canceling that to be left with a 3. And today, that thought of getting a common base is going to be the critical piece to what we're focusing on. Okay, now let me show you what I mean by that. So today we're going to investigate a little bit more difficult examples, a little bit trickier examples. So one big idea the big idea is to write the main number as a power of that base, okay? And sometimes we need some tricks in order to get there. The first trick I'm going to give you in your toolbox is going to be negative exponents, okay? Because remember, negative exponents manipulate where the value is in a fraction, okay? So here, what I need to do, I need to rewrite this main number as a base 2, okay? Now, the first step is kind of easy because 4. How can I rewrite 4 as a power of 2? Well, hopefully that comes pretty naturally to you. Isn't 4 2 squared. So again, the big idea, we need to get those bases to match. Okay, now there is one issue. They still don't look alike. Okay, that 2 squared is in the denominator of a fraction, while the base of the logarithm is just this regular 2. So that's where this negative exponent piece comes in. Okay, because I can use the negative exponent to move things around. So that 1 over 2 squared. Well, instead, if I just make its exponent negative, that lets me move it up to the top. I can move its location in the fraction because I've applied a negative exponent now. And now look at those two bases. Those two bases are identical, 2 and 2. So they're going to cancel off, leaving it with a negative 2. So again, answering the question, what power does 2 need to become 1/4? Well, it needs a negative 2 power. Okay, and again, you can confirm this if you plug it into the calculator. 2 to the negative 2 power, boom, it does give you 1/4. Same idea for this next one. I need this 27 to match that 3. I need to rewrite it so it matches the base of the logarithm. Well, if I'm looking at 3, oh, wrong thing again, I apologize. If I'm looking at 3, well, 3 to the third gives me 27. Okay, so that's the first simple manipulation I can make is 27 is just 3 to the third power. Okay, but again, notice now there's an issue, right? So the base of the logarithm is just 3. I have this fraction now, okay? And the good news is, though, I can manipulate that. That 3 to the third that's on the bottom of that fraction, remember, I can move it up if I make its exponent negative. Okay, and now those bases perfectly match. So now I'm able to slash them off and just be left with that negative 3. 3 to the negative third power is going to give me that 1/27th. All right, and what about that next one? So here I need to rewrite that 64 as base 1/4, okay? Which probably seems a little bit weird. Well, the nice thing is in the get-go, 64, rewriting it as a base 4 or base 1/4. Well, the first thing I would recognize is 4 to the third power gives me that 64, okay? So the first thing is we have 1/4, and 64 is just 4 to the third power. Okay, so I'm one step there. Okay, at least I have the 4s. But now there's a difference, okay? Because now I have a 4 and I have a 1/4. So the number I just created is in the wrong location of a fraction. Okay, in fact, I need to create a fraction out of this. Well, to create a fraction, to move something around, since I need that to be a 1/4. To move that down, I need to give it a negative exponent, okay? Whenever something is in the wrong location, use a negative exponent to move it around. Because now those bases match perfectly, and I have negative 3. And again, you can easily check that in your calculator. That 1/4 to the negative 3 power does in fact give you 64. All right, so that's the first trick, using negative exponents. All right. Now, sometimes you actually don't need a negative exponent. So here, what if they're both fractions? Well, then it actually gets pretty easy, okay? So here, I need to rewrite this 8 as a 2. Well, hopefully that comes pretty naturally because you know, hopefully by now, 8 is 2 to the third power. So that 8, I'm going to change that to be cubed, okay? So 1/2 cubed is how I can get an 8 there because 2 cubed is 8. And now the nice thing is, don't they already match? They're both already fractional bases. So here, just because they're fractions, well, it doesn't mean I need a negative exponent because they already match. These already are going to cancel out and just leave you with 3. So again, the big idea here is 1/2 needs a third power to become that 1/8. Same thing right here. I need to rewrite that 125 to have a base 5. Well, again, pretty easy from the get-go if you remember that 5 squared gives you 125. So if you remember that, okay, now again the nice thing is both of them are fractions, so actually those logs already cancel perfectly to leave you with 2. So again, basically telling you 1/5 needs a power of 2 needs to be squared in order to become 1/25. So again, that's the big idea on how you deal with fractions, okay? You deal with fractions mainly with negative exponents unless you have both of them as fractions, then the negative exponent isn't necessary, okay? Next piece, okay? Roots and powers are connected. So for example, a square root is a 1/2 power, cube root is a 1/3 power, so on and so forth. This is another big idea of this chapter, and what is kind of cool because it relates it to chapter 6, which we've already done. Okay? So now the interesting thing here is I need to rewrite this 9. I need to write it as base 81. Okay? Well, to rewrite it in base 81, well, how is 9 related to 81? Well, hopefully you remember 9 is the square root of 81. Okay? So here I'm going to bring those back in. I'm going to bring in the radicals. Okay? So to change the 9 to match the base, I have to recognize 9 is the square root of 81. And from there, recognize that roots and powers are in fact connected. So remember, square rooting is the same as having a 1/2 power. Okay, and the reason that's important is because now that I've manipulated this, now I have both bases as 81, so the logarithm sets free that 1/2. Again, you can see it makes sense. 81 to the 1/2 power does give you 9. Now, of course, we can throw some more angles in there, all right? So now I need to rewrite this 7 as base 49. Now, again, at first that probably seems a little bit weird. So if I want a 49 there, well, 7 is going to be the square root of 49. Okay? So now, again, same logic as before. Well, a square root is the same as a 1/2 power. However, if you notice, just like on the previous slides, isn't that in the wrong location? because you have a base 49 for the logarithm, but now that 49 is in the middle of a fraction for the main number. So again, that won't do, okay? They have to match perfectly. So what does it take to move something in a fraction? Well, it takes making the exponent negative. Okay, so making that a negative exponent, now these match perfectly. And we will get -1/2. And again, you can easily check that in the calculator. 49 to the -1/2 power does give you 1/7. Okay, so it matches perfectly. Now, there are some slightly more complex ones, okay? So I'm going to show you one of these. And even though this isn't really my focus, this is more of a challenge type problem, just to be something nice and thought-provoking for you, okay? So log base 9 of 27. So the interesting thing here is 27 is not a power of 9, is it? Oh, I'm sorry, I keep doing that. So if you look at powers of 9, 27 isn't on it anywhere, but 27 is up here, okay? 27 is 3 to the 3rd power. So here, while we can't directly jump to the 9 yet, we can at least get on the right track, okay? So if I still want this written as a base 9, though, because I need the bases to match. Well, if I want this as a base 9, hopefully you agree, if I need a 9 in there, isn't 3 the square root of 9? So here we have to change the base twice, okay? We're going to change it to a 3, then change it to the 9. That's how they're connected. And again, just like before, well, square rooting is the same thing as a 1/2 exponent. And now the real loop here is power of a power. So I can multiply those exponents to give me 9 to the 3/2. So again, this one is a little bit more involved, a multi-step problem, thinking through all the way, how do I get to that answer? Well, now finally, those slash out, and you're left with the 3/2. So if you take 9 to the 3/2 power, let me convince you, 9 to the 3/2 power, it does give you that 27. Okay, so again, that one's more of a challenge, but it's very good at showing that you truly understand the manipulations of these types of problems, okay? How to use the roots as fractional exponents and negatives. So, a couple interesting cases, okay? So that first one, what power does 6 need to become a 1? Well, here the interesting thing is anything to the 0 power gives you 1. So really, that would always be a 0. No matter what the base is, if you're looking for it to equal 1, that's going to take a 0 exponent. Okay? And then finally, that next one, log base 2 of -4. All right, so there, that one's a little bit tricky, okay? So what power does 2 need to become -4? Well, if I try to square it, 2 squared, it gives me 4. Well then, okay, I'm looking for a negative number. Maybe it's a negative exponent. So maybe it's -2. Still doesn't work. So the interesting thing here is you actually can't do it. Okay? You can't toss a power on a number and make it negative. That's never going to happen. So here, this is one of the conditions, is you actually cannot take the logarithm of a negative number. Okay? It doesn't end up working. So, again, just a little side note, that'll actually help us tomorrow when we start graphing, to remember that you can't take the logs of negative values. All right, so let's toss in a word problem, and then we will call it good for these notes. So many measurements of physical phenomena have such a wide range of values that the reported measurements are logarithms or exponents of the values, not the values themselves. When you use logarithms of a quantity instead of the quantity, you're using a logarithmic scale. The Richter scale is a logarithmic scale. It gives logarithmic measurements of earthquake magnitudes. So I'm hoping you guys have heard of the Richter scale, okay? And again, it varies so much that that you use logarithms because you're spanning over such a wide array of numbers. So in 2004, an earthquake with magnitude 9.3 on the Richter scale hit off the northwest coast of Samaria. The diagram shows the magnitude of an earthquake that hit Samaria in March 2005. The formula log of I1 over I2, so comparing the intensities, equals the difference in their magnitudes. Okay, and it compares the intensity to magnitude. How many more times intense was the December earthquake than the March earthquake? So how many more times intense was it? Well, here we're given a magnitude 9.3 and given a magnitude 8.7. All right, so how many times more intense? Well, let's take a look at this. So log of comparing the intensities is going to be 9.3 minus 8.7. So the difference in their magnitudes is 0.6, okay? But we want to figure out how many times more intense is it. So we want to be able to compare the intensities. So we need to set those intensities free, okay? Now, something you probably noticed, that logarithm doesn't have a base on it. So when it doesn't have a base, remember, it's assumed to be 10. It is a common logarithm. So if we want to compare the intensities, we have to break it free from the logarithm, okay? To break it free from the logarithm, remember, we learned some of those manipulation techniques, okay? If we use Mr. Loopy on this, 10 to the 0.6 equals I1 over I2, we can use that to compare these intensities, okay? So really all we have to do is let's plug that into the calculator. 10 to the 0.6 power. So it was almost 4 times greater, okay? 4 times stronger. So that's something where it looks like such a small difference, comparing 9.3 to 8.7, but that had 4 times the strength, okay? So again, it's cool to recognize how that relationship works, and that's what logarithms do, okay? So we've covered a lot of good stuff today. So I do need to make sure that you write that summary for me. Write down some of the key things. Talk to me about negative exponents. Talk to me about fractional exponents, all of those things. And then make sure you come back ready tomorrow so we can do our practice work.